Hello and welcome back to Quada's Leetcode. Today I'm going to be doing problem number 572, subtree of another tree. So for this problem, you're given the roots of two binary trees, root and subroot. And you need to return true if there is a subtree of root in subroot, and false if it's not. So basically, you want to see if subroot is subroot a subtree of root. And how do you know if it's a subtree of root? Well, basically, all of subroot needs to be found in the exact same structure as within root. So you found there's a root node of 4, and then it has a child of 1, a left child of 1 and a right child of 2. So you found that same thing as a child of root. It can either be the root can equal subroot, or one of its children, a child of root, is equal to subroot. So you can see that in this case, what the left child of root is equal to subroot. So looking at the tree, you can easily be able to tell if subroot is a subroot of root. But how can you do this programmatically? Well, you can use a recursive definition, and basically you can use the two cases that we were talking about. If root is equal to subroot, or if a child of root is equal to subroot, then you know that you need to return true. And if that is not true, else return false. So in order to do this, you're going to need a helper function that tells you if two trees are the same. And we actually did a problem like this in a previous video where it was the problem number 100, same tree. So we made a function to determine if two trees are the same. So we're actually going to call that function in this. So we're going to check if the subroot and the root are the same, or the subroot and one of the children of root is the same as subroot. And so that is going to be the algorithm. So let's see it coded up. So the first thing you need to do is take care of edge cases. So what if there was no root, but there was something in sub? So first off, what if there is nothing in subroot? So if not subroot, if there's nothing in subroot, then is an empty tree a subroot of a tree? Well, yes, it is, because a tree can contain a empty, if we were looking at, let's go back to our drawing, and let's go back to the drawing, and if subroot was empty, is none, well then root could have none as one of its children. And so that's actually, that's actually a subroot. So because one of the children is equal to the subroot, which is none. So let's go back. So if there's no subroot, then return true. But if there's no root, so if there's nothing in root, but there's something in subroot, then there's no way that could be the same tree, because the nothing doesn't match with a tree. So if not root, you need to return false. Okay. Now we know that there's going to be something in subroot and there's going to be something in root. There's going to be at least one node in each of these trees. So now we want to check if they are the same. So this is the part where we need a helper function. So we're going to write it as if we have that function already, and then we'll write that function. So if self dot is same tree for root and subroot, if they're the same tree, so subroot needs to be capitalized right there. So if they're the same tree, then we want to return true. And if they're not the same tree, then we want to see if one tree, we want to see if our left child, if so we're going to call this function, if self dot is subtree, is the left a subtree? So we're going to give root dot left and subroot. So is the left tree a subtree of this tree? Or is if the right is a subtree, then so we want to return that. And if one of those is true, then we return true. And if both of those are false, we return false. So let's write our helper function is same tree. So for that, we're going to be, we had P and Q, and so if not P, so we already did this, so if you want to see a full explanation on how to do this problem, go back and watch my video. Problem number 100 is same tree, but we're going to replicate it here. So if not P and not Q, if both of those are empty, then we're going to return true because they're the same. And if not P or not Q, one of them is empty and one of them is not, we're going to return false. Now we're guaranteed for both of them to be at least one node. So we're going to say if P dot val equals Q dot val and and the left subtrees are the same. So and self dot is same tree p dot left and q dot left, and the right subtrees are the same. Self dot is same tree p dot right and q dot right. So if that is true, if p and q at the root are equal, and the left subtrees are equal, and the right subtrees are equal, then they're equal. So this is all the code. So what this is going to do is this is going to check if the roots, if the trees are exactly the same. If the trees aren't exactly the same, then it's going to call this function and on the root dot left and the subroot, and then it's going to check if the root, if the left child is the same as the subroot, and then it's going to check if the is subtree. Then it's going to go into the right subtree is going to be the essentially the root, and we're going to check if that root is the same as the subroot. And so in that way, we're going to check if if the subroot is the subtree of the root. So let's run this. And we're getting I put too many ors here, if not P or not Q. And it should be is subtree lowercase. Is there any more problems? I think it's good. And we're getting a correct answer, so let's submit. And it was accepted. So that's how you solve that problem. Thanks for watching, and I'll see you in the next video.